Hey, yo, my name is Achilles, and I've been thinking about circles lately, specifically portions of circles. We call these circular arcs, and the distance of the arc as you walk along it would be called the arc length. We can calculate that distance with what's called the arc length formula. Some of you may know this already, as S equals theta, the radians of the arc, times r, the radius of the arc, or of the circle that the arc is a portion of. This is all well and good, but the formula seems a little too simple. Why does it look like that? In order to get to that, we'll have to look into radians. Who? Heh, your mom. But on a more serious note, think of a circle whose radius is flipped up and subsequently curved, bended on the circumference of the circle here. If you took the end of that point there and drew a line from the center of the circle, you'd get an angle. That angle is equal to exactly 1 radian. In order to help remember this, keep in mind that radian is pretty close to radius, and that's for a reason. We get a radian from using a radius like this. Now, you can put multiple lengths of a circle's radius next to each other a few times. And in fact, you can do it 3 times before you run out of space to add a 4th one on half of a circle. Interestingly enough, this little piece that's left is a portion of the length of the radius exactly long enough so that it contains all the digits of pi, but not the 3. So it's 0.314159 blah 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 lengths of this radius long. It's a portion of the length of the radius. Now, if we add the 3 lengths of radius that we had before then in half of one circle, we end up getting pi. And that's what we mean when we say that half of a circle, 180 degrees, is equal to pi radians. Similarly, if we wanted to get a whole circle, you just multiply by 2. And a whole circle is 2 pi radians. Keep in mind that a radian is not a unit of measurement for distance. You couldn't take a line and say call it 5 radians. It doesn't make sense because the line doesn't have a radius. With a circle, however, or with a portion of a circle, we do know that it does have a radius, so it makes sense, according to the definition of a radian, to use radians in that way. Wait, that's not right. Nice. In order to move forward, we'll need to talk about the circumference of a circle. We're all familiar with the formula c equals 2 pi r. The circumference equals 2 pi times the radius of the circle. Keeping in mind what we said earlier about a circle being 2 pi lengths of its radius, we can see here a visual representation of that. 6 lengths of the circle's radius with a little bit here representing the decimal points for 2 pi. And the way to represent this little bit here without using all the digits would be simply calling it by 2 pi minus 6. It would be all these digits minus 6, and we get the decimals. An example where we can put in concrete numbers, let's say the radius is 5, we can add up the lengths of radius, 5, 10, 15, 20, 25, 30, and we have this little bit here that we multiply by that decimal string. But we can multiply that 5 by 2 pi minus 6. And we can make a formula here for that. And similarly, if we replace the 5 with r for the radius, you can see here how if you distribute the radius on 2 pi minus 6, you end up getting 6 times the radius minus 6 times the radius plus 2 pi r. And algebraically, we can see here how the circumference is equal to 2 pi r. Now, finally on to the arc length. Let's say we have an arc that we know is 1/4 of a circle. We know that its radius is 10 feet, but we want to find out the arc length. Knowing that this arc is 1/4 of a circle actually helps us if we look at an entire circle. So knowing the circumference of a whole circle, because we have the formula already, if we know how much of an entire circle this arc length is, then we can solve for the arc length of this. Going forward, if we know it's a fourth, we just multiply the circumference of that circle by 1/4, and we plug it in. We see that we get 1/2 pi times the radius. We plug in the radius and we get 5 pi. But if we have an arbitrary arc that we don't know how much of a circle it is, how can we solve for this? Fortunately, there's a piece of information that they often give with arc lengths, and that's the theta. That's our kicker. No, not the liquor, the kicker. There we go. We know a whole circle to be 2 pi radians. How much of a whole circle it is equal to the radians of the arc divided by the radians of a whole circle. And moving forward, we can multiply that proportion, how much of a circle it is, by the formula for the circumference of a circle. The 2 pi's cancel out on each side, and at the end we have the arc length formula. Thank you everyone for watching. I do gaming streams on Twitch from 9 p.m. to 11 p.m. Monday, Tuesday, Thursday, Fridays, and I also have a Discord whose link is in the description. Hopefully I'll be doing more videos soon. Watch out for those. Goodbye.